So this is the answers to the rock and mineral pretest. So now you've taken the test, you can actually look at the rock and mineral. So this might go fast, but that's okay. You have the ability to pause the video. So number one, this is a piece of potassium feldspar. It has cleavage. It's a very important rock forming mineral. You see this a lot in porphyritic granites. It has great cleavage. So number one is K-spar or potassium feldspar. Number two does not have cleavage, even though it has a crystalline structure to it. This is actually quartz. It's crystalline quartz or milky quartz. Very hard, scratches glass really easily. Very hard mineral. So on the hardness scale, it's a 7. So it's a very hard mineral. Very glass-like, because basically that's what it is. It's nature's natural glass. Number three, another important rock-forming mineral. This one has 6120 cleavage. This is amphibole or hornblende. Very hard. It'll scratch glass. It is a silicate mineral, black in color, very high temperature silicate mineral at the top of Bones reaction series. And this is amphibole or hornblende. So number three, amphibole or hornblende. Moving on to number four, another important rock-forming mineral. This is muscovite. So there's two different micas we have seen in igneous rocks. Muscovite, kind of a silvery color. Basal cleavage, very, very vitreous luster. It shines light very nicely. Can actually be almost translucent, transparent, in thin sheets, so it flakes off in very thin sheets. We call that basal cleavage. So number four is muscovite. Number five, the unique property behind this rock is that it is the only mineral that is magnetic. So this is actually magnetite. Magnetite is very magnetic. Very high density, leaves a kind of a gray streak, high specific gravity, and it's magnetic. Number six, this mineral will not scratch glass. It's not that hard. And this basically is fluorite. Fluorite comes in many colors, has excellent cleavage, often forms octahedrons. We've seen it in the octahedron form. So this is fluorite. Calcium fluoride is a chemical composition of it. So fluorite. Number seven, if you were to lick this, which I don't advise people lick anymore after the coronavirus killed everybody, this is almost a translucent, not quite transparent, but translucent mineral. Cubic. This is a nice piece of halite. So halite. Number eight, easily marks on paper, as evident by the markings on the. This is a piece of graphite, very soft, kind of greasy feeling. It's used actually in pencils as pencil lead. What people call lead in pencils is actually graphite. Pure carbon, well, not really pure carbon, but it's made out of carbon essentially. Number nine, kind of looks like graphite. It will barely mark up on paper. And this is actually a very heavy. It does have cleavage. It is galena. It has cubic cleavage, and it's one of the rare metallic minerals that actually has cleavage. So that's galena. Very high specific gravity. The most dense mineral of all the minerals. This is the heaviest because the atoms are so close together in lead that it forms a very heavy, dense mineral. And the last mineral, number 10, known as fool's gold. This is actually pyrite. You can see the pyrohedrons, a little clustering of the pyrohedron crystals. This mineral does not have cleavage. It fractures, but it does form crystalline structure. But if you break it with a hammer, it'll fracture randomly. So that ends the minerals. We're now going to jump over to the igneous rocks. So the first igneous rock, number 11, this is a granite. Nice phaneritic texture, has visible minerals, all the same size. It has some muscovite in there, which is silvery shiny material. It also has some quartz. And I think a little bit of amphibole got snuck in that one. So that is a granite. Very felsic, means it's quartz rich. Number 12, an extrusive igneous rock. This is vesicular basalt or scoria. It has holes in it. Lots of volatile gases were part of this magma. This magma would have been very mafic, iron rich. So this is vesicular basalt or scoria, number 12. Another volcanic rock, extrusive, but cooled very quickly, comprised mostly of quartz. Because the composition is mostly quartz, this particular mineral is actually felsic. Even though it's black in color, obsidian is actually felsic. But it has just a little bit of iron got in there to make it black. But if you were to take a thin section of this obsidian, it's almost transparent. So obsidian, extrusive rock, very felsic even though it's black. Another very felsic but intrusive igneous rock is this one here. This is called a granite pegmatite. So pegmatites are very large minerals. You can see by the appearance of the big piece of potassium feldspar and the silver microminerals. So this is a granite pegmatite or pegmatitic granite. Very felsic. Number 15 here is an intermediate rock, half quartz composition and half iron. So the black mineral in this rock is amphibole, and the white mineral is actually plagioclase. So this is called intermediate in composition. It is an intrusive igneous rock of intermediate composition. Its extrusive equivalent would be a, I can't even think of the name right now, diorite. This is the diorite, and the andesite basically is the extrusive equivalent. So number 15. Moving on to number 16, very lightweight rock, full of holes. It is made out of glass. Its cousin is obsidian. Basically, this is a piece of obsidian that blew up. This was obsidian with lots of gas in it. So this is actually a piece of pumice. Very lightweight, floats in water, full of very fine holes. We call this texture frothy. So that's pumice. We're going to go across the room to finish up the igneous rocks. So at the end of the table here is the igneous rock number 17. You can see that it kind of has a really cool green color, very granular. The green color is due to the mineral that's present in this, which is olivine. But we don't call this rock olivine because it's not a mineral, so we call this a dunite or peridotite. So we're calling this a dunite or peridotite. Number 18, potassium feldspar present in this rock as a phenocryst. That means large mineral. The phenocryst outsizes all the other minerals in this particular rock. This is actually what we call a granite, a porphyritic granite or a porphyry granite. So it's a porphyritic granite or a granite porphyry. The phenocryst in this case is potassium feldspar. Number 17, a very felsic rock that's extrusive, cooled very quickly. This is rhyolite. So rhyolite cools very fast, very quick cooling. No real minerals that are present to the unaided eye. So we call this texture aphanetic. That means no visible minerals. And the last of the igneous, number 20, this is an extrusive rock. This is asphalt tuff. You'll see fragments of rock and maybe even obsidian fragments in this rock. This is volcanic tuff, so we just call this a volcanic tuff. Let's move now on to the sedimentary rocks. So the first rock, number 21, is really a piece of oil shell. This is a shell that's dark in color, brown, and it's very rich in organic material. But in our class, we're just calling things shell. So it doesn't matter if you call it claystone, siltstone, we're just calling everything shell. If you want to get technical, this is a good example of an oil shell. Classic sedimentary rock, layers to it, a good example of shell. Number 22, another classic sedimentary rock with larger fragments of potassium feldspar in it. This is what we call an arcosic sandstone, a very dirty sandstone. On basically everything, it's not a well-sorted sandstone. It's got fragments of larger chunks in it. Kind of occurs close to the weathering site, close to the granite rock that it weathered out of. This is an arcosic sandstone, a classic sedimentary rock. A chemical sedimentary rock, or even biochemical, is coquina. Coquina basically is a bunch of shell fragments all cemented together. The source for this rock is Florida. You see a lot of this in Florida. This does react to acid, hydrochloric acid, so it does consist of calcite. This is a biochemical or chemical sedimentary rock. Number 23. Number 24. This is a hematitic sandstone. It's a fine layered quartz sandstone, and the red coloration is due to iron oxide or hematite. So it's not just iron, because iron by itself makes the rock turn black. This is iron oxide. So number 24 is called a hematitic sandstone. And then 25 and 26 I put together for a reason. Here's number 25. This is a classic sedimentary rock. The class that make up this rock are gravel fragments. So because the gravel fragments are angular, this is what we call a breccia. So this is a breccia. And number 26, very similar but rounded class of gravel. This is a conglomerate. So 26 is conglomerate. We have another sandstone here, but this sandstone has no red coloring to it. This is well sorted, fine grain, basically wind blowing, quartz sand. This is basically a quartz sandstone, number 27. 28 reacts to acid, therefore it's going to consist of calcium carbonate, calcite. This is chalk. It easily writes on paper. You can see the writing that's going on here. So this is chalk. Number 29, this does react to acid, so therefore it's going to be calcite based. This really, says is really easy. You can see a fossil in here. This is what we call phospholiferous limestone. So limestone rocks that have fossils in them we call phospholiferous. Say that real fast 3 times. Number 30, a nice layered sedimentary rock, very dark, very organic rich. This is a piece of shell. This is about as claystone as you're going to get. Nice piece of shell, claystone. And that ends the sedimentary rocks. Now we're going to go to metamorphic rocks. And so 31, 32, 33, and 34 follow the metamorphic grade from low grade to high grade. This is basically slate, Fred Flintstone's boss. Slate basically is a dull, flat sedimentary or metamorphic rock. Its sedimentary rock parent was a shell. So a dark shell is going to form a dark slate, a red shell is going to form a red slate, and so forth. So this is slate. Basically what's happened here is you took the sedimentary rock, the shell, you put it under heat and pressure, and you fuse together the clay minerals, and this is basically a slate. One grade up from a slate is a rock with a slight little shine to it, usually a wavy texture. This is called a phyllite. So this is the little higher up than the metamorphic grade. This rock basically tried to have minerals present. The minerals could not make it to the surface, and so the shiny surface is probably due to quartz and muscovite. The next grade of metamorphism is schist. This rock is loaded with visible minerals. You can see the visible minerals, the mica certainly. Sometimes you'll see garnets. I think you can see a garnet right there. That is actually a garnet. So schist, basically, one of its index minerals is garnet. Layered rock, nice in layers. Its parent was actually a phyllite. The phylite's parent was a slate. The slate's parent was a shell. And the highest degree of metamorphism is rock number 34. This is a gneiss. This gneiss has 2 minerals in it. It has layers of amphipole and layers of potassium feldspar or K-spar. And so the pink mineral here is potassium feldspar. The black mineral is amphipole. So we're now going to finish up the metamorphic rocks, go across the room here. And rock number 35. This is definitely foliated. So metamorphic rocks, you have 2 textures, foliated and non-foliated. This rock has a green color to it. It is actually a green schist. So the green color is due to the chlorite mica. The white mineral is actually plagioclase. So number 35 is a green schist. Green stones don't have layers to them. They're just basically a massive green rock. 36 reacts to acid. Therefore, it's going to consist of calcite. This is a piece of marble. It will not scratch glass. You cannot scratch glass with marble. It's too soft. And it basically consists of calcium carbonate. And this is where the marble, the fine grain calcium carbonate actually started to grow in the marble. And so number 35 is a marble. 36 is a marble. Number 37 looks similar to the marble. This is fused quartz. The parent of this rock was a sandstone. So this is actually basically a quartzite. So quartzites are made out of quartz. The quartz is fused together during the process of metamorphism. That's 37. 38 is another schist. This one is actually loaded with garnets. You see lots of garnets in this particular schist. And then the silver mineral is the mineral muscovite, mica variety muscovite. This is a schist. Number 38 is a schist. Number 39, its parent was a conglomerate, a sedimentary rock conglomerate. And this is called a metaconglomerate. It consists of fused together gravel-sized fragments and a quartz matrix, very hard rock. This is a metaconglomerate. And our very last rock of this set is number 40. This is a pure piece of carbon almost. This is what we call anthracite coal. The parent of anthracite coal is bituminous coal. So the difference between the bituminous coal and the anthracite coal is the sedimentary bituminous coal is rich in sulfates and has a lot of plant material still on it. As this coal became metamorphosed into the anthracitic coal, basically the sulfates were driven out, the mercury, all the bad stuff, and you're basically left with pure carbon. So technically you could take this nice piece of pure carbon coal, put it under a lot of heat and pressure, and it'll form a diamond. So I may be a whole hunk of coal right here, but it could be a diamond someday. So that is anthracite coal. And that ends the review of the metamorphic, sedimentary, igneous, and the minerals. So hopefully this finds useful for you.